టీ తీసుకొచ్చాడా ఎలా hello is it audible hello
Yes, sir.
right Russ, last class what we were doing Nana? Hmm. Right Nana. So we are discussing alkanes, right? In alkanes, the last class in the preparation of from alkenes, from alkynes, so and from aldehydes and ketones. Clemmensen reaction, Wolff-Christian, HN friends of red phosphorus, from carboxylic acids, decarboxylation, and coal-based electrolysis. The coal-based electrolysis, we prepared alkanes, alkenes, as well as alkynes. Next, put the heading and Grignol reagent also we discussed. The Grignol reagent, what we did? So, Grignol reagent plus any proton donor, we will get alkanes. Done. Next, put the heading Urge reaction. Urge reaction. How many of you know Urge reaction? How many of you know Urge reaction? RX, alkyl halide with 2 NAs. So once again, one more alkyl halide, we are just I'm taking here. In presence of dry ether. What exactly happens now? This is going like this, 2 NaX, RR clubbing is takes place like this, RR plus 2 NaX, 2 NaX. Write it down. I'll explain the mechanism. For example, CH3 CH3Cl plus 2Na ClCH3 dry ether. What we will get? We will get ethane. Okay? Right. Write the products. 2 moles. Come on, write the products now. ప్రోడక్ట్ బై ప్రోడక్ట్ రాదా బై ప్రోడక్ట్ తీసేస్తాం మనకి మెయిన్ ప్రోడక్ట్ ఇది బై ప్రోడక్ట్ వస్తుంది కదా తీసేస్తాం. సో మనం టీ చేస్తాం, టీ పౌడర్ అవన్నీ వేస్తామా, రైట్? దాంట్లో టీలో టీ పౌడర్ ఉంటుందా? మనం ఏం చేస్తాం, ఫిల్టర్ చేస్తాం కదా, ఫిల్టర్ చేసేది సో మనకి మ్యాంగో తింటాం, మ్యాంగో మొత్తం తింటామా, బై ప్రోడక్ట్ ఏమొస్తుంది, సీడ్ వస్తుంది, పక్కకి వేస్తాం. ఇక్కడ కూడా వస్తుంది, ఎంత బై ప్రోడక్ట్ వస్తుంది. మనం ప్రిపరేషన్ ఆఫ్ ఆల్కేన్స్ మనకి ఏది కావాలో తీసుకుంటున్నాం. ఇక్కడ ఏమవుతుంది మనకి, what we will get, butane, in this case hexane. What we can see, what we can observe over here, in this case also we are getting symmetrical alkanes, means even number of alkanes we are using. In this case, can we prepare methane? So they are asking some questions, which of the following reactions we cannot prepare methane? The coal based electrolysis, can we? Now they'll ask the question like that, which of the following reactions we cannot prepare methane? So like that. So we'll see the mechanism. Rasava? Sodium is there, for example, in the mechanism, no? And one more important thing, dry ether, I told you. If we'll take wet ether, what exactly happens? I told you in this case, dry ether. If you are taking the wet ether, what happens? Wet ether, if you are taking, so sodium is highly reactive, Nana. So if you put sodium in water, explosion takes place. So whenever if you are doing the in wet ether, what happens? Right? Explosion takes place. Mokal pachadaipothai. So that's the reason we can't use. So the face will become tetany. Yeah. Sodium is highly reactive, right? So the mechanism, Nana, sodium is Na plus electron. Na plus electron. So this Rx, there is two types of mechanisms we can understand, right? So here the electron is coming and attacking over here. No? So R radical plus X minus. If 2 moles, if you are taking RR, R radical plus one more R radical, will get RR. That Na plus and X minus will becomes NaX. NaX. This is one type of mechanism. Write it down. What's the reaction, right? So RR only, NaX, right? This is Rx plus Na, right? It is radicals, Nana. So completed. ఎందుకు? శౌర్య అంట. హౌ డిడ్ యువర్ స్టూడెంట్స్ పర్ఫామ్? గుడ్. చదివిన వాళ్ళు బాగా రాశారు, చదివిన వాళ్ళు రాయలేదు. ఇట్స్ వేర్ ఎవర్ యూ గో. అదే చెప్తున్నాను. చదివిన వాళ్ళు ఎప్పుడైనా కానీ బాగా రాస్తారు, చదివిన వాళ్ళు దాంట్లో ఇక కొంతమంది బాగా రాశారు, కొంతమంది మీడియేట్, కొంతమంది చదివిన వాళ్ళు. సో try to understand. For example, CH3 radical, one more CH3 radical. Here is two types of reactions are there: combination and disproportionation. Combination means just combining. When in this case, when 1 degree radical, so only combination reaction is takes place. CH3, CH3. Write it down. Only combination. Combination means just both are combining. Even if you are taking one more CH3, CH2 radical, CH2 radical, CH3, right? Here is also only combination is takes place. Only combination. Hi Meghna, not writing. Combination is takes place. Only combining. If you are taking the second 2 degree radicals, means సూర్య నువ్వు ఎక్కడి నుంచి? శౌర్య ఎక్కడి నుంచి? టైప్ చేయి. నువ్వు ఎలా రాసావు? So in 2 degree case, combination as well as disproportionation both are possible, right? So what is combination and what is combination means directly combined. CH3, CH3, H, CH, CH3, CH3. So this is combination. Combination as well as disproportionation reaction is takes place. What is disproportionation? For example, try to understand. CH radical, right? So now this undergoes homolytic cleavage, this hydrogen. One is alkene and one is alkane, we will get. So means what? This hydrogen is going to attack over here and this radical combining with forming a double bond. Means what? CH3 double bond CH2 plus CH, H is coming over here, CH3, CH3. This is we are called as disproportionation. Oxidation reduction is takes place. So it's losing the hydrogen means reduction, sorry, losing oxidation, gaining the hydrogen means reduction. So disproportionation is takes place. This is disproportionation. 2 degree case, what exactly happens? Disproportionation reaction is takes place. 1 degree case only, combination is takes place, whereas in this case disproportionation is takes place. 2 degree. So here is CH3, right? Can we write CH2H? So this undergoes homolytic cleavage. So means what? H radical is coming, right? H radical is attacking over here and one more radical is there. That radical combining a double bond here, like here is the double bond is forming. right? And this hydrogen, this is this hydrogen. One is alkene, one is alkane. Disproportionation is takes place. Combination means directly simply combining here. For Urge reaction, this is better, Nana. 1 degree radicals are better. Because if you are taking the 2 degree, two types of products are forming. If you are taking 3 degree carbon radical, only disproportionation is takes place. Shaurya, type చేస్తున్నాడా? Right. In this case, what exactly happens? Only disproportionation. Now, how it happens? You can take this side, this carbon or this carbon, right? Can I take CH2H like this, right? Homolytic cleavage takes place like here. This hydrogen is coming and attacking over here. This radical and this radical forming a double bond. Means what? CH3, double bond CH2, CH3 plus H, CH3, CH3, CH3 is taking place. Disproportionation takes place. So what is my main intention is that 1 degree is combination takes place. When we are taking the 2 degree, both are possible. When we are taking the 3 degree, only disproportionation. Write it down. ఇప్పుడు ఎలా ఉందిరా? లైట్ బంద్ చేస్తే బాగుందా? చేస్తే బాగుంది. అది ఎక్కువ వస్తుంది కదా? ఇది ఓకే కదా? డన్ రా. Right. So one of the important thing is we can't prepare methane in this. Hello. Right down. We can't prepare methane in this reaction. And write one more important point. We cannot use to prepare odd number of alkanes. Odd number of alkanes means what? For example, CH3Cl, 2Na plus Cl, CH2, CH3. Triether. Sir, in this case, propane is an odd number. Is it possible, right? Yes or no? Hello? Propane is possible, but we are not using. Why? So propane we will get here. But what exactly happens? Why we are not using this? Anyone? Odd number of alkane possible, right? But mixture is forming. Very good. Buy one, get two free. Buy one, get two free. Ante, imagine this is 1 mole, this is 1 more mole. So in previous cases, what we did, only one type of molecule we took, right? Imagine in a box, only A type of molecule is there, the combination would be AA type. No issues. For example, in a box, AA type is there as well as BB type is there, right? What happens? How many combinations are possible? AA possible, BB possible, AB possible. So means along with propane, we'll get this react with one more molecule of this, ethane as well as butane, right? Plus ethane as well as butane. So these products are all are what are homologous series. Only CH2 difference is there, homologous series. Like, for example, we want propane, but along with ethane and butane is forming. Separation is very difficult, right? Because all are homologous series and very close properties. For the preparation for methane, for example, if you are spending 10 rupees, for the separation it costs 1000 rupees, right? Is it preparation 3 rupees only, but separation is very difficult task because all are similar physical and chemical properties. Similar, like for example, try to understand two twins are there, right? First time Ram Lakshman is there. The second time when we are watching them, if we want to say who is the Ram and who is the Lakshman means, it's very difficult task for us. Ram ko Lakshman bolte, Lakshman ko Ram bolte, right? Because it's very difficult because similarity is there. Otherwise, if two different people are there, we can easily recognize. That is the important thing. Buy one get two free. Mixture of products are forming. So that's the reason we can prepare, but we are not using to prepare odd number of alkanes. Write that point. So in Wurtz reaction, we are not using to prepare odd number of alkanes. Odd number of alkanes because mixture is forming. Homologous series. What is the meaning of homologous series? The compounds are differed by CH2 group. Nana. Write it down.
Carboxylation
In alkanes chapter lo so we have different methods, but the ఇంకా ఉన్నాయి వేరే చెప్తాను. ఉన్నాయి వేరే కూడా ప్రిపేర్ చేయొచ్చమ్మా. Here is in place of dry ether we can use THF, tetrahydrofuran. Tetrahydrofuran also we can use THF. Zinc వాడము ఇక్కడ. ఏమంటా అర్థం కాలే. టెరబుల్గా నేను లక్నోలో ఏం చెప్పనే मैं मैं लखनऊ में नहीं पढ़ा था, मैं हैदराबाद से हूँ. कौन है वो, उनका नाम क्या है? Thank you for watching and commenting. So in Urju reaction, if you are using instead of sodium, that is Franklin reaction. Okay. So Franklin reaction, same reaction, everything is same, but mechanism is different. We are using the zinc. So dry ether only. We get RR plus Zn X2. So this reaction we called as Franklin reaction. Franklin reaction. This is ionic mechanism, no? Ionic mechanism. And we are using same like symmetrical preparation of symmetrical alkanes. We will use symmetrical alkanes. Actually, it's not in our syllabus, but in place of sodium, if we are using zinc, so one more name reaction is coming, right? So that's the reason we need to learn. Next, in case of Urju reaction, the percentage of yield is how much, no? Percentage of yield. Percentage of yield, yesterday I told you, right? pH 3 degree, 1 degree, then 2 degree, then 3 degree. In this case, I told you alkenes are forming, right? Alkenes are forming. Write it down. Percentage of yield in Urju reaction. Write it down. Next one, preparation from carbides. Preparation from carbides. Preparation from carbides. Preparation for carbides. So when carbide, aluminum carbide on hydrolysis will get methane. Aluminum carbide. So even beryllium carbide, Bu2, very important, Bu2C plus hydrolysis will get methane. Beryllium carbide and aluminum carbide will get Methanes, put 5 star. Put 5 star. Nana. రాస్తురా ఏమని రాస్తున్నారు ఏమైనా బూతులు రాస్తారా ఏంది? ఏమని రాస్తారు మరి? కోనే హితేష్. థ్యాంక్ యూ హితేష్. So 5 star, no? So very important is the beryllium carbide and aluminum carbide. Next, no. Berthold's reaction. Berthold's. C plus 2H2 nano. At high temperature, 1200 degrees centigrade, electric arc will get methane, CH4, like it. So it's a industrial method. Next, miscellaneous reaction, CO plus H2, right? Nickel in presence of 250 degrees centigrade, you get methane plus H2. So miscellaneous reaction, just write it down. Ni plus here is carbon will use. So these are the preparations of 4A house synthesis is there, but it's not in our syllabus. First thing is we need to follow the NCERT textbook. There's lots of other reactions are there, but those reactions are not needed. Or A1 is right, Anna. So Urju reaction is clear, right? From carbides. So now write the products. This is a homework for you. Otherwise, write here itself. So I'm giving the questions, write the answer. అరే ఎయిర్పోర్ట్ పోతున్నాను. ఎంఎస్ చేయడానికి వెళ్తున్నా. ఏ స్టేట్లో ఉంటుంది? నేను కూడా వెళ్ళాలి అమెరికాకి. టైం దొరకట్లే. వీసా ఉంది నాకు. చెప్తాను రా 2-3 రోజులు. ఐపీ కూడా స్టార్ట్ అవుతాయి కదా ప్రాక్టికల్స్. ఆల్మోస్ట్ ఆల్ సిలబస్ అయిపోయింది కదా మీకు. నేను అదే కొత్త బ్యాచ్ స్టార్ట్ చేయాలా లేదంటే మీకే మళ్ళీ రివిజన్ పెట్టాలా అది చూస్తాను. ఇట్లా ఏం చేద్దామంటావు? Reduction of alkyl halides also will get alkanes, no? Even from alcohols also. HN points of red phosphorus if you are using. And glucose, ra. But अब बोलो क्या करेंगे कृष्णा भाई? कृष्णा भाई अब बोलो क्या करेंगे? कितना मार्क्स आ रहा?
80 में
केमिस्ट्री पे. Write it down. Write the questions. టైప్ చేస్తున్నారా? I had no idea that our teacher led double lives in 2 different states. Whatever the doubts you people are having, so you can text me. अब सब्सक्राइब किया, अब देख रहे, सब्सक्राइब कर दो ना. शौर्य ना वो कौन है वो? Hmm? Hitesh. Right. So these are some questions. Next, put the heading physical properties of alkanes. Physical properties of alkane. Physical properties of alkane. So physical properties, no? Alkanes, alkynes, almost all are similar, but it varies. So melting and boiling points are important here. But even though, so what is exactly physical properties means? Whether they are liquids or gases or solids, what is its density, what is its boiling point, what is its melting point, right? And what is its solubility. For example, alkanes are, right? For example, if you are putting in water, so water is down, or alkanes are down, which is floating, which is floating. So these are fuels, right? Petrol, diesel, hydrocarbons. So they'll float on the water, lighter than the water. So write it down first. Up to C1 to C4, Nana. C1 to C4 are gases, are gases. C5 to C14, C14. Colorless, write it down. Odorless, colorless, odorless, colorless, odorless, colorless, odorless liquids. Colorless, odorless liquids. Colorless, odorless liquids. Reason. Reason also write it down. Right. Reason also write it down. Due to increase, due to increased in the surface area, due to increased in the surface area, due to increased in the surface area, van der Waal. Van der Waal forces of attractions are increases. Van der Waal force of attractions are increases. Van der Waal force of attractions are increases. Van der Waal force of attractions are increases. increases down the group, down the homologous series, not the group, down the homologous series, down the homologous series. Next, density. Density. What exactly happens when number of carbon atoms are increases? What about density? Krishna, write it down. Lower number of alkanes are less dense than the water. They are denser than the water. And alkanes are soluble in, alkanes are water, polar or non-polar solvents. Alkanes are what, Nana? So here is one statement is like dissolves like. What is like dissolves like? Like dissolves like means what? Polar compounds are soluble in polar solvents, non-polar compounds are soluble in non-polar solvents. Write that statement. Polar compounds are soluble in polar solvents, non-polar compounds are soluble in polar. Alkanes are polar or non-polar? Alkanes are polar or non-polar? I don't know. Alkanes are polar or non-polar? Alkanes are polar or non-polar? Akshita? Krishna? Krishna? Hamsini? Non-polar. Non-polar. What is polarity in non-polar? Water is there, for example. H2O is what? Water is what? Electronegative difference is there, right? Water is polar. CCl4, benzene, etc. These are all ethers, are non-polar. Sorry, non-polar. So alkanes are non-polar, dissolves in non-polar solvents, but not polar solvents, but not in water. Okay, water is a polar solvent, right? Alkanes are not soluble in water, right? That statement. Alkanes are not soluble in water because alkanes are non-polar, water is polar. What is polar means? If the electronegativity difference is there, that is we are called as polar. HF is there, for example, the polar, partial positive, partial negative charge, partial positive, partial negative charge. Like, so alkanes are non-polar, they are soluble in non-polar solvents like CCl4, benzene, etc. etc. They are not soluble in water. If it is water, these are soluble, like alkanes are floating on the water, less denser than the water, less denser than the water. Write it down. Next one. This is clear, right? Polar and non-polar. For example, naphthalene balls are soluble in water. Naphthalene balls we are using in toilets or in clothing, some smelling purpose, right? So those are, that is non-polar compound. Water is polar, so that's the reason it's not soluble in water, right? So we need to know polar and non-polar. How should we identify polar? Means in chemical bonding we discussed, right? Electronegativity difference is there, those are polar. If electronegativity difference not there, for example CCl4, so there is no movement of electrons, dipole moment is zero. Sorry, right? Simply like dissolves like polar compounds are soluble in polar solvents, non-polar compounds are soluble in non-polar solvents. So alkanes are non-polar, that's the reason they are not soluble in water. They are soluble in non-polar solvents like CCl4, benzene, etc. Boiling and melting points, Nana. BP and MP, not Madhya Pradesh. Melting point. BP means consolidating. BP ante Opala. Opal is capital city, right? Bed pressure. BP, boiling and melting points. Write it down. Boiling and melting points are increases with increasing the molecular weight. Boiling and melting points are increases with increasing the molecular weight. Right. Boiling and melting points. Boiling and melting points are increases increasing the molecular weight, because van der Waals forces are increasing, surface area increasing, van der Waals forces also increasing. Van der Waals force of attractions are increasing because surface area increases as well as van der Waals force of attractions are increases. Here is one of the important question and examiner's favorite question, 5-star wala. One sir, 5-star wala. Write it down, 5-star. When I am putting the 5-star means what? There is a huge probability to ask the question. So which of the following is more boiling points? More BP. Which of the following is more BP? What is BP? Which one? What is the answer? So the following is more boiling point. Your answer is D. You only telling na? Don't know, sir. No. Option D na? You only told. Don't know, sir. What is the answer? Important, na? Boiling point is inversely proportional to branching. Boiling point is inversely proportional to branching. Boiling point is inversely proportional to branching. Right? There is more branching, less branching, no, very less branching. Because more van der Waals force of attraction, more surface area, more van der Waals force of attractions. That is the reason. Write it down. More surface area. What are these names? Sometimes they are asking instead of structures. So they are asking the names. This is what? N-pentane. This is 2-methyl butane or isopentane. isopentane. This is neopentane. 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 Done? Next, melting points. Melting points. Alkanes are having more melting points, even number of carbon atoms. Write it down. Alkanes are having even number of carbon atoms. Alkanes with even number of carbon atoms have higher melting points. Then the next lower and higher alkanes. Higher alkanes having odd number of carbon atoms. Having odd number of carbon atoms. So means even number of carbon atoms and odd. For example, try to understand. No? Butane is there, right? There is propane is there. In this case, pentane is there. So now the butane, right? Even number of carbon atoms, right? Is having what? Closed pack structure. It is possible closed pack structure because the two ends are opposite direction. Whereas in this case, for example, if you can take the pentane, what have ends are same side. So closed packing structure not that much of possible. In this case, closed packing, because, write it down, because of closed packing structure. Because of closed packing structure. In case of even number of alkanes are having closed packing structure because the ends are opposite direction, right? This is down, this is up right now. Hello, if you can take hexane, what exactly happens? This end are, yeah, number of carbon atoms. Next one, heat of combustion. Alkanes are highly inflammable. And having high heat of combustion. The heat of combustion value increases with the increasing number of carbon atoms. The heat of combustion value increases with increasing the number of carbon atoms. more number of carbon atoms, more high heat of combustion. For example, same number of carbon atoms are there like this, butane and isobutane. Which is more heat of combustion? Yeah, let me know. Because number of carbon atoms are same. Hmm? Write it down. A only. Heat of combustion for isomeric alkanes, because both are same isomeric, right? C4H10. Here is also C4H10. For isomeric alkanes, write it down. For isomeric alkanes, the heat of combustion decreases with increasing in the branching. If the branching is increases, heat of combustion is decreases. Now let hmm? 1, 2, 3. Write it. But in case of stability order is reversed. For example, if I am taking cyclopropane, cyclobutane, cyclopentane, cyclohexane, like this, for example. So cyclopropane is highly unstable, easily is breaking, right? So it is reverse in case of cyclic cases, stability cases. Write it down. Heat of combustion, stability order is reverse order of heat of combustion. Done? So mainly concentrate on boiling point. Boiling point is very important. This is boiling point is inversely proportional to branching. And so polar and non-polar alkanes are non-polar. Why non-polar? Because carbon and hydrogen are almost all similar electronegativity. There is no movement of electrons. Next, so C1 to lower members, not only in alkanes, in all chapters, lower members are gases. Middle members C4 to C5 to C15, C16, somewhat it varies. So those are liquids, and higher ones are solids. And I told you, write these questions, answers. If you have any doubt, let me know. So Franklin, Berthollet. Next, chemical properties. Chemical properties of alkanes. Chemical properties. Alkanes are generally inert in nature, less reactive. Alkanes are less reactive. Why they are less reactive, Nana? Huh? Because they are saturated hydrocarbons. Saturated hydrocarbons. Alkenes and alkanes are more reactive when compared with alkanes. Alkanes because saturated hydrocarbons. Saturated, already carbon is having the. So I told you, alkanes generally undergoes which type of reactions? Alkanes undergoes free radical substitution reactions. Recently in the reaction mechanism I told free radical substitution reaction, right? For example, CH4 plus Cl2, sunlight. What exactly happens? CH3 Cl. This is a chain reaction. Once the reaction is started, it's going. So once again, the CH3Cl will react with Cl2, sunlight. You get CH2Cl2 plus HCl is going out. Next, CH2Cl2 plus Cl2 CHCl3 plus HCl. CHCl3 plus Cl2 CCl4. Can we do one more? Already 4 hydrogens are replaced by the substituted by the chlorine. Already recently I told you, right? The mechanism is also told. I told you this mechanism, chain propagation is important. The mechanism, chain propagation is important. Go and type just rara. Mechanism I explained in the recent last classes, right? Mechanism. First step, Nana, chain initiation. Chain initiation means just started. Cl2, for example, Cl2 sunlight. So we'll get 2 Cl radicals. Then chain propagation is important. I told you. Chain propagation. Chain propagation. So chain propagation steps are important. For example, methane, Cl radical, right? CH3 radical and HCl is going out. How it is happened? CH4. Can we write like this? The homolytic cleavage takes place, H radical and Cl radical. And the CH3 radical once again treating with Cl2. Cl undergoes right now. CH3 radical and Cl undergoes homolytic cleavage. One radical is coming and attacking over here. One more radical is CH3 Cl plus Cl radical. The Cl radical goes back and attack the CH4. Once again what happens? CH3 HCl. The CH3 comes and attacking the Cl2. So this process is keep on, right, propagating until unless all molecules, all methane are completed. So in the last step, what exactly happens? Chain termination takes place. Chain termination takes place. Chain termination. For example, 2 Cl radicals are remaining. So Cl, because these are forming very trace amounts, right? Very trace amounts. So we will not consider, for example, one CH3 radical, one Cl radical is there, CH3 Cl. 2 CH3 radicals are remaining. Sir, in this case, ethane also forming now. You don't tell that in the beginning, right? So because these are right negligible. So chain initiation, chain propagation, chain termination. The most important thing is, what is most important thing? Right? 5-star. They keep on asking chain propagation step because a lot of people are confusing CH4 plus Cl radical, CH3 radical is forming in the first step, then CH3 radical Cl2, this keep on propagating. Very, very important. So remaining, I'll continue tomorrow, okay? Remaining chemical properties. So revise all the reactions, whatever the reactions you are having the doubt, right? You are facing any doubt, so let me know. I'll explain once again those reactions, okay? But it's all about initial. It seems to be somewhat difficult for the 11th class guys. For 12th class, it is easy. If you are, in 11th, you right heard once again 12th class. It's all about the repetition and the practice. So do a number of times practice and try to write the products which I already gave you here. These products, try to write the products. Okay. Right, Nana? So Wurtz reaction. So here is Berthollet reaction, Franklin reaction, boiling points, melting points. Boiling points are inversely proportional to branching, and heat of combustion is also inversely proportional to branching, like that. So we discussed. Hello. So we'll continue tomorrow.